Hey, good afternoon. This is Tim Vasquez. We're checking this event coming up for North Texas and Southern Oklahoma over the next few hours. I don't know if we're going to do this as a continuous live stream, but we'll take a look at the situation right now and this is the first time I've really looked at it myself. I wanted to start kind of like with a clean slate here and go through the situation just as you might do on a severe weather day. So starting with the big picture, we have our radar here. This is the reflectivity from Dias. So we've got a definite cyclonic shape. Let me pull up my draw tools right here real quick. And that cyclonic appearance that I'm talking about is this S shape that we have here. So this is indicative of some sort of cyclone, maybe in West Texas, definite baroclinic system, and we can switch over to the surface chart real quick and check that out. In fact, I'll stop right here. This is the visible satellite imagery. This is going to be for this is about 9 minutes ago. And this shows a little bit of that cyclonic shape that we had here. So you see that going on right there. Got the dry slot coming in on the south side. We have some higher based towers out near Lubbock and the Tahoka area. Also have some convection starting to go up around Clovis. You see that right there. That's going to be high based also. One way we can kind of tell is because of the lack of low clouds out ahead of it. So it's probably bringing in some air with higher relative humidity. The better moisture is a little bit further to the east, along the cap rock right there. All right, so that's the satellite presentation right there. Switch over to the surface chart, and I'll just do a quick one. This is my links page on weathergraphics.com/WX, and here we have the surface chart. And the first thing that we want to know is where the dry line is. Well, what do we have on here? We've got a lot of 60s across Texas, along the East Texas, I-35 area. We go out to the big country in the Concho Valley, we're looking at 60s. And those don't really fall off until we get to the Sweetwater area, maybe even a little bit further west. So here we have 50 at Midland. That's a good sign. We have the dry line right there. And where does it go further north? Well, we've got 60 right there. That looks like Crosbyton. Lubbock reporting about 59. So dry line is still pretty far to the west. Then as we go further north, it starts bulging out eastward. So we're looking at, there's 28 right there at Shamrock, 55 there at Clinton. So we're going to bring that a little bit further east. So that's the dry line appearance right there. Okay, do we have any fronts? That's the first thing I would look at as far as if we have something coming in from the west or the northwest. And I don't really see any evidence of that. We've got 67 there at Albuquerque, which is going to be, it's slightly on the cool side, but what we want to see is westerly winds there if we have a front coming in from the Arizona area, Four Corners. Don't quite have that, so this looks like mostly a dry line situation. The last thing I would look at is anything in the warp sector. Well, we've got 82 around Corpus Christi, 84 there at Cotulla. Go up further north and we've got 81 at Paul's Valley, 84 at Oklahoma City. So we've got a pretty homogeneous warm sector, don't have any real fronts going west to east. We would also want to think about if we've had any convection in Texas or Oklahoma over the past 12 to 18 hours, because that would lay down some outflow boundaries. Well, we haven't had any of that going on. So we're not going to expect to see any real east-west boundaries. Alright, as far as our conveyor belt of warm air, I'm going to be looking at stronger winds. What do we have for winds out in East Texas? We've got south winds at 20 to 22. We go to the I-35 area, we've got south winds at 25 to 20. And they pick up a little bit around Sweetwater and Abilene. We've got, let's see, I can't really read that right there. We got 29 there at Sweetwater, 27 at San Angelo, so maybe a little bit of localized, a little bit of a concentrated jet right there, coming up northward through the Concho Valley. Nothing really further east. But I do see a little bit of veered flow here, so this suggests that there's probably an outgoing shortwave in eastern Kansas, western Missouri, and we're kind of in between systems in North Texas, and next one coming in from the west out in New Mexico. So it'll probably be a few hours before things really get going. I'm probably not going to be here the whole time. I'll probably end up shutting down the live stream and kind of wait and see for maybe a couple hours. And if we get things really going later in the day, I'll probably go ahead and restart our stream here, because it's still pretty early. Let me switch over to the visible, or I'm sorry, to the radar right here. There we go. So this is the big picture. We've got a little bit of very disorganized storm activity right there around Jayton. There to Post Texas. This is the Cap Rock right here. You kind of want to be aware of where that is, because that's an area of enhanced upper level lift, although we're not seeing that so much today because the flow is parallel mostly to the Cap Rock. So it's kind of coincidental that storms are going along that. However, this is probably our first initiation right there west of Jayton. The stuff near Abilene really hasn't got going, and it's probably a little bit high base still, because I can see that the reflectivity kind of trails off as we get close to the radar site and picks up further to the southeast. See it right there? There's the stuff out near Comanche, Stephenville, and let's see, I'm trying to remember the cities out there. I used to drive through there all the time, but right now I can't really recall individual cities. Let me bring up the tilt a little bit. We want to see what's going on at higher elevations of the radar, and it looks pretty much the same deal all the way up. There we can see a little bit of the storms out near Albany. Well, those are going to be mostly showers. Tops on that are going to be, let's see, about 15,000 feet. As we drop down to the stuff in Jayton, we see tops of about 31,000 feet. Where am I getting that? I don't even have to look at the radar echo tops on that. I can look at the display here at the bottom of GR level 2. See this right here? This gives us a readout of where the cursor intersects the radar beam at this particular elevation. Let me shrink this box over so you can see the elevations. It's going to be this control panel right there. So we're on the 3.2 degree tilt. If I drop down to 2.4, I start picking up more of this stuff here in near Jayton. What's our height on that at that elevation? That's going to be about 24,000 feet. The stuff is still relatively shallow. We've got a top there of about 31,000 feet. Nothing above that. So this is still kind of a little bit early in the day here. So this is new convection. And the other thing that we look at to tell whether this stuff is severe is look at the tilt as we get into higher elevations. Mostly what I'm seeing here is the tops are just kind of sheared over downstream like that. Don't see any like overhang to the southeast, that kind of thing. So let me drop back down to 2.4 and 1.9. Okay, so this is again just new convection, and I would say not severe at this time. So we go up further northwest. There's some more storms right there, east of or west of Plainview. That'll probably be a player later today as it gets towards the deeper moisture. So that'll be tracking out towards South Plains, Memphis, Childress probably. What moisture does it have to work with? Well, let's take a look at this one more time. Dry line looking like that. Our cell is just behind the dry line, and the moisture it's tracking into is not very, look at that, 55 there at Childress. That's not very good. It's probably not going to be tapping deeper moisture till it gets all the way near Frederick. So this is, well, let me look downstream. 57, 59 there at Jayton, 62 at Abilene. So that cell does not really have access to deeper moisture. However, you're going to see more photogenic structure with that. And then the better stuff is going to be down to the south. And what kind of moisture is that sitting in right now? 59 degree dew points, that's better. Of course, we should really look at the soundings to make sure we're not just going by, 60 is severe, 75 is, or 65 is severe, 55 is not severe. We don't really want to go by that. We want to look at the soundings because things do vary from day to day. So for our soundings, we're going to look at Fort Worth. What kind of dew points do we need to have to make this severe? Okay, this isn't the ideal sounding to be looking at because a lot of lines aren't labeled on here, but I can kind of do a quick summary for you. Okay, let's take that 75 over 60 that we have out there. Let me double check that. Yep, 77 over 60. I'm going to put that into the sounding right here. 77 is going to be about like that. 60 is going to be about 16 to 17 degrees Celsius. So this is going to be our lift. So it's just going to give us a very quick overview of what these cells are looking like. So we got a little bit of a cap right there. The cells have managed to penetrate that. They may be somewhat elevated, but in any case, as the parcels continue rising, we're looking at, this is probably about maybe 1,000 to 1,200, 1,300 joules per kilogram of CAPE. That's going to be on the marginally severe side if they can keep going. So to really, yeah, this is pretty much looking like we need dew points above 60 on this particular day. If we have a 65 dew point, what is that? What does that give us? I'm going to put in 75 over 65. You can see that gives us a much better parcel lift, a larger CAPE area. This is going to be probably about 2,000 to 2,500. So the moisture is very critical on a day like this. The main problem that we're going to have for today is dry air entrainment because, well, we got about 1,000 millibars of moisture. That's going to be about 4,000 feet thick. The reason it looks kind of weak on this particular chart, this is a 12Z. The moisture was weaker this morning. It's probably changed a bit, and to get a handle on that, we can look at the Del Rio sounding, because that's going to advect northward during the day. So what do we have at Del Rio at 12Z? They had dew points of about 63 Fahrenheit. That's about 17 C right there. I'm looking at the 10 and the 20 here. So about 63 right there, and that goes all the way up to about 870 millibars. That's about 120, 130 millibars deep. That's a pretty good depth. That's going to support deep, long-lived cells, assuming we can break this cap that we have, which is going to be weaker as we go north. So right now it's a matter of just getting things going. As far as severe weather potential, let's see here. Let me take this sounding right here. I'm going to start with 17 Celsius, 120 millibars deep. I'm going to go over to Fort Worth and kind of combine that. So here's 17, 120 millibars deep. I'll go with maybe 24 to 23 for evening conditions. Let me redraw that. That's a little bit messy. Okay, so this is going to be our proposed parcel lift. Going to look something like that. There's our LCL. Let me draw that on. That's probably what we're looking at for a parcel this evening, and you can see it's a little bit on the weak side, so I don't think we're going to get like raging supercells, anything like that today. Because of this, I would really like to see a stronger lapse rate, and we should actually check this with the model data to find out what the temperatures are aloft, because we got to consider changes aloft. And I don't have too much time to do that right now because I'm going to kind of wait and see as far as today. But we could probably take a quick look at a few products. Let's see, anything else to look for? Let's see, we got westerly winds aloft. Southwesterly at 850. And I think to really get some good rotating storms, we really need the winds to be backed on a day like this. Because you can see that the hodograph, see that up here, it's sort of straight lined, and we don't have any good strong southwest mid-level winds. We got 15 knots there. That gives us a little bit of a area where we can develop some storm relative helicity, but what I'd really like to see is the wind profiles looking a little bit more like, well, maybe not like that, but let's see. We want to see something like that for good storm relative helicity, which means strong southeast winds at the surface. Up at 850, we want to see a strong low-level jet, 25 knots out of the south. And we had a little bit of that right off the surface. But I'm not sure if we have that right now. I would have to look at some model data. Let's see. Rapid refresh. It's probably about time to look at a little bit of model data to see what's coming up. So I'm going to go to RAP plots right there. Then when this panel comes up, I'm going to shift to Central US. There's no data in here for 18Z, so we have to go back to 17Z. And there we get some products. So what I'm going to look at right here is the 850 millibar winds. So what is the wind situation looking like for 0Z? Well, we've actually got a low-level jet, 35 knots there across North Texas, so that's pretty decent. See it right there. But you can see that outgoing shortwave. It's let me drop the panel down a little bit. So there's some sort of storm system right here in Missouri that is basically pulling the wind field northeast like that. So this is pretty veered. What we're wanting to see is a little bit of that backflow ahead of the next system. 850, well, that's going to be a little bit on the... I'm kind of stumbling here because I really need to draw this out on a photograph to kind of show you. But the important thing is, yeah, we do have southerly winds at 35 knots, so that's a little bit of low-level jet energy. And with that, all we need to really squeak out some good helicity for rotating storms is southeast winds at the surface, like that. I'm not quite sure we have that today. So this is going to give us a little bit on the linear side for helicity. So let's look at that surface wind field. We'll pull up this 2 meter dew point. Let's do that right there. So here's our wind field at 0Z. Looks like kind of a meager wind flow out of the south at 15 knots. And you can see that's the direction is equivalent to that of the 850 millibar flow. So this isn't really helping things any. However, the other thing is the dew point. The yellow pattern is going to be 60 degrees and above. So it looks like that does put a little bit of moisture out ahead of that cell near plain view. That's going to be moving eastward. So assuming this pans out, that might give us something to work with. However, we need to verify this model. Let's see, it's 20Z. I want to see if Childress is reporting the same thing on the surface as the model suggests. So I'm going to go to our current dew point and see if that verifies. And it actually does. See, Childress is going to be about right there. That puts us in the blue pattern. So it's suggesting that the dew points at Childress are going to be about 38, and you can see that they're a little bit higher than that. Where does it pull the higher moisture from? It looks like it's this field just to the south around Knox City, Stamford, Seymour. That's probably going to be in place and probably advect northward. So this is suggesting a little bit of backing and bringing that moisture northward, and then by 1Z, which is this evening, looks like it's got a little bit of moisture in place. This is mostly off the Cap Rock and a little bit further east of there as you go south. So basically from about Abilene to Knox City and then back to the Cap Rock here around Turkey and Memphis. So yeah, this is the area we're going to focus on for later this afternoon going into this evening. So it looks like about Childress down to about Seymour, maybe a little bit further south depending on if stuff gets going down there. Now one thing we can do is we can kind of cheat. We can go to the high resolution rapid refresh. We can set that on south central US. Hey, there's no data in here that's current. All they got here is 12Z. I don't know what's going on there. Let me switch this over. We'll try the operational model. South Central US, 12Z. Yeah, there we go. We got 18Z data. And we'll take a look at what the high resolution rapid refresh looks like, what the mesoscale models are suggesting. And I will pull up the 23Z which is 6 p.m. Actually, you know what I should do is I should pull up a verification panel for 2Z. Or I'm sorry, 2 hours and ahead, 20Z. This is current. It's got nothing developing across North Texas. Does anything get going by 4 o'clock according to the model? Well, this is interesting. It's got stuff going further to the southwest. This is going to be around Big Spring up to Tahoka. And what we've seen on radar is stuff developing out in this area here. So there's already a little bit of divergence between the mesoscale models and what's actually happening right now. Then the situation by 6 p.m. they've got stuff developing south of Childress, Seymour down to about south of Sweetwater. Also some stuff developing way down here around Del Rio down to Eagle Pass. So you can see that stuff is a little bit more prominent to the south. Probably some stronger lift down there. And then the scenario they've got by 9 p.m. is isolated cells around the I-20 area, around Abilene out to Stephenville. It looks like a big glob of almost tropical stuff to the south. I remember there was a good strong cap on the Del Rio sounding this morning, so it looks like we're getting some very good lift working that area down around I-10. And we'll run this up to 4Z. That's going to be about 11 p.m. Some more activity between Abilene and Fort Worth, and then our more tropical stuff down around San Antonio. And then the final frame, 2 in the morning. It's like we got some stuff around Oklahoma City. Got a little bit of a bow echo shape to it right there. So let me back that up to 9 p.m. and see how that stuff started. It started out as convection along a boundary. Kind of looks like an east-west boundary right there, west of Oklahoma City. And then I'll back that up further to 6 p.m. So it looks like some organization of some cells maybe after midnight in Oklahoma City. That's just something to look ahead and keep in mind as we go through some of this data. Where did that come from? Lost my surface chart already. Okay. So you see what's going on right there in Kansas. Didn't quite see that on the first surface analysis. It looks like we have a cold front coming southward. So that's the other feature in addition to that dry line. That dry line is located something like that. So this suggests to me that we're probably seeing that cold front advancing southward, and then we see some organized storms developing along that. Is that backed up by the models? (2 p.m. dew point, or 2 meter dew point. 5-hour forecast, 23Z. Yeah, by 6 p.m. you can see they've got that front coming into the earthquake capital of Oklahoma, Lamont, down to Gage, and then to trying to remember the name of that town in the northern panhandle. It starts with S. 2 meter dew point. Then by 10 o'clock, there's our boundary. You can see what the wind field is doing here. There's a little bit of a chaotic look, and what I'm seeing here is a little bit of outflow. You see that divergent appearance. So the model is pointing out a little bit of an outflow boundary there in southwest Oklahoma, the main front coming like that. So things are sort of coming together a little bit in Oklahoma. This doesn't look to be a big severe outbreak, but Should get some strong storms there around Oklahoma City later, probably as that cold front comes south. And I don't know exactly what's going to happen along the dry line. It looks like it's just going to be, we'll just have to watch and see what happens here. Then we got the tropical stuff down in San Antonio area, and there's some good upslope out down there. See that? Get east-southeast winds coming in from Corpus Christi to Del Rio. And we've got westerly winds around Chihuahua coming into the Big Bend area. So looks like a bit of baroclinicity, maybe a system coming through. And we can take a quick look at the upper level charts and see what's going on there. 500 millibar vorticity, that's good for a first look. So here we've got 4 p.m. data. Of course, this is just a forecast, mesoscale forecast. And it looks like a little bit of cyclonic curvature in the height field. Kind of flattens out here. You can see a ridge. So it looks like we got a ridge kind of parked over Texas, North Texas. A shortwave trough working through that ridge, kind of flattening it out. And we got more energy. This is a very noisy field, as you can see, but I'm kind of like picking out details. Looks like maybe there's a bit of a shortwave trough out in Mexico right there. I don't know whether it's affecting the Del Rio, San Antonio area because it's so noisy down here, but what I can see for sure is this shortwave trough right now coming through Lubbock, Abilene, and it's probably responsible for setting off those cells that we see right now around Abilene. So we don't like seeing a big ridge over the area this time of day. So things are a little bit out of phase with the daytime heating. That's the main problem we're looking at. So I'll switch back over to the radar. Where am I? Yeah, there we go. So already got a severe thunderstorm warning on that cell west of Plainview. It's probably going to be mostly for gusty winds and maybe a little bit of hail. Main cell of the day is right here around, let's see, Stamford. That's going to be around Guthrie right there. So just southwest of Guthrie, Texas. Picking up some good reflectivity there. However, it still looks a little bit disorganized at this time. Going to higher tilts, well, you can see we backed up a little bit in time. Actually, the radar data caught up. Okay, we're 39 after the hour. Yeah, okay, here's where it backs up. 39 after the hour to 35 after the hour. Okay, now it updated. Okay, so 39, 39. What I'm doing is I'm looking at the tilt as we go with height. Okay, now we're at 35, 39, 39. I don't see a whole lot of tilt over into the inflow area. So this looks to be kind of non-severe at this time. But if you're out there, at least it's something. Okay, here we've got a little bit of overhang actually. See the higher reflectivity right there? Let me set a dot right here. I'm going to place a marker to show where the higher part of the updraft is. This is going to be up at 39,000 feet. We even pick up a little trace of it up at 49,000 feet. Probably the bottom of the beam cutting into that. And we drop down further south. Yeah, it looks like it's developing a little bit of tilt, although you can see we've got some newer cells developing out a little bit ahead of it. So what's going to happen with this thing? Well, it's marginally severe, if anything, and it's likely going to track, let's see, what's our movement? Movement is northeast about 030, 020. So this is going to track up towards the Crowell area. If it becomes severe, it's probably going to become a little bit more of a right mover, move towards the area north of Seymour. So probably this area right here. Anyway, not a whole lot to really worry about at this time. The stuff we had developed further south, you can see that's kind of diminished. So this is a lot of forced type convection, probably riding northeastward with that shortwave. And I don't know how fast the shortwave is moving, but that may carry it quickly northeastward, and then we'll probably see nothing at all for a couple of hours, and we'll be watching for maybe some more stuff to develop. That's kind of what the model suggested, maybe towards sunset, a few cells developing down here. We could really nail that down for sure if we started going through surface charts. You know, we start looking for boundaries, good areas of low-level forcing. I'm not going to really do that right now, but you can see that we don't really even have a boundary. We've got a dry line. Okay, so this is our best trigger right here as far as the low-level convergence. See that strong west-southwest wind right there at Midland, converging with south-southeast winds there at Big Spring. This is probably what I'm looking at over the next couple of hours, is this I-20 area, stronger convergence. And that will track probably northeastward as the dry line advances, a little bit further eastward during the afternoon. So probably I'd be watching this area for new development. And of course we want to look at the satellite data. And that kind of bears it out. See right there around Big Spring? Got a few towers there. This looks a little bit more vertical. This would be north of Big Spring right here. See that right there? So this is probably going to be our next area to watch. And I'm kind of betting that this stuff here mostly moves on off the activity near Crowell and Knox City. I don't know how long that's going to keep going, but if it does hold together, that'll probably move towards the Wichita Falls area over the next few hours. Then we got this stuff here, and then the activity north or west of Lubbock, that could also track westward. However, the main problem here is that if the activity near Knox City increases in intensity, it's going to start laying down outflow boundaries and messing up the moisture field, which would affect the storm here as it tracks eastward. So it's going to be feeding off regurgitated moisture unless it can develop a new moisture feed to the south. And let's see what else. You can see it looks like some strong upper level lift down here around the Big Bend. That's probably what the models are focusing on for the San Antonio area later this evening. Okay, let's see here. Okay, I was replaying. I was checking on our page here for the video to see if there was any chat going on, and I think right now we're just waiting for things to develop. I think what I'll do is I'll probably go ahead and stop for now, and then we'll fire things back up if we get any severe weather going. And we'll come back and do that. And I think, I'm trying to see if there's anything else I want to cover. I think that's about it. We'll just keep an eye on the channel, and I'll try to put up a notification if it looks like we're going to go back on. Otherwise, I'll just cut in live and we'll see how it goes. And we may be on tomorrow if there's anything going on in North Texas. We normally don't cover the area out around Arkansas and Louisiana. I'll bring up that SPC outlook for you. Okay, there's the SPC outlook. And then for tomorrow, so we may be active for this. So Dallas-Fort Worth is going to be in this area. This is going to be a little bit east of there. And normally when storms get out into the Shreveport, Little Rock area, I don't really plan to cover this unless it's a PDS watch type day. But for something like this, yeah, sure, I will probably fire things back up tomorrow, and then we'll check that out. So anyway, keep an eye on things for later today and tomorrow, and we'll see you later. Thanks for watching, and just check back, and I'll figure out how to turn off the stream. I'm still getting used to all this stuff. And there we go. Okay, well, thanks. I appreciate it. Bye-bye.